My name is Marek Wiewio rka, as already introduced, and together with my friend, Verdan Mahmood from ING, we would like today to seize the opportunity and tell you a few of our experiences, share of our lesson learned from the implementation of data discovery and data lineage for one of the TM and ING, namely Wholesale Banking Advanced Analytics team. Those of you who attended the Big Data Tech conference last year may have a pleasure to see the presentation by Chris Adamski and Rob Kivill, who introduced the data analytics platform and its principles as a whole to you. This year we would like to focus on some only specific aspect of this platform that we have been working for the past year, namely the data discoverability, and how we can achieve it using Apache Atlas and Amundsen. Okay, when I'm thinking about the analytics landscape in the year 2020, two things come to my mind instantly. First of all, the open source software have become de facto the standard for doing advanced analytics. No matter whether you are using Python, R, or SQL, all of them are powered by free machine learning libraries and algorithms. And what is even more important, all of these tools have very low entry barrier, meaning that you don't have to be a fully fledged data scientist to run very sophisticated analysis. Everything is available to you, and things like automatic feature selection, hyperparameter optimization, or AutoML in general come to play and help you to run this analysis without any effort. The second thing, on the single organization level, is that whenever you try to apply this powerful method to your data, you are constantly in the need of finding the information, the reliable information, what are the data sources that you need to prepare these algorithms, and also in the information metadata that build the trust around the results you are achieving. And this is actually when data lineage and metadata come to play and support the development of machine learning and data democratization. So Verdan, why data democratization is so important and ING?
Yeah, absolutely. Thank you so much, Mark. So let's just back up and talk about why data discovery, why effective data discovery is really important, and why are we even talking about data discovery? That's because of this one. This is our purpose. This is the purpose of our team. We build algorithmic 10x data-driven products that benefit our clients and generate revenue for the bank. So the purpose is really ambitious. The goal is ambitious. And data is the only way to make informed and objective data-driven decisions. Not just this, but also security. GDPR, we are a bank. We have responsibility to handle your data in a responsible way. So we definitely need to know what data are we working on? What are the different types of data? What is the different versions of data that we are working on? Who is responsible for this data? What are the upstreams and the downstreams of the data? So we need to know all of these things. And this does not really apply on any one role. It applies on many roles. Data scientists, they want to explore the data. Data engineers like myself, we want to know, we want to validate our choices that we're making using the data. And of course, the product managers or business people, they want to generate reports, the target marketing and that part. So everyone needs data. But how do you make data-driven decisions? The process can be divided into 4 steps. The first step would be you would always search for the data. You would try to understand the data. And using that data, you would perform the analysis, or perhaps you would have some visualizations and other things. And then, based on your visualization or your analysis, you would make a decision and share your insights. The 50% of the process is data discovery. searching and finding the data, and then understanding that data is data discovery. Let's take a hypothetical example. You are a new user in our team, or you just switch your projects. And you really want to work on this very cool bond trading experiments or bond trading projects within a bank. What would you do? The first challenge would always be to know where is the data, to search and find the data. How would you search or find the data? You would ask your friend, your coworker, your existing team member, or you would ask your manager, hey manager, I want to work on this particular thing, where is the data? Or you would start searching in the Slack channel. Maybe send a message in the general channel like, hey, I want to work on the bond trading experiment, where is the data? Or finally, if you are lucky enough, you would simply search in the Git repositories to search for the ingestion code, like where is this data? Perhaps you would find multiple data sources after this, perhaps. The next challenge would be to understand that data. Suppose if previously you find multiple data sources, 2 or 3 data sources, you need to know which one is correct, which one is up to date, what is the different column means, because of course they have the different kind of column names. What do different column means? You would start using SQL static commands. First, you would search for first 100 rows, or perhaps that won't work for you. You would start for complete table. You would start for static, find all the table, and try to understand the data. According to research, data scientists spend up to 1/3 of their time in data discovery, which is like 30% of their time. Do you really want your data scientists to spend their 30% time just on data discovery? Definitely no. We want them to focus on analysis. We want them to focus on analysis work to make their analysis, make their models, and those kind of things. And also, it's a drain of resources for your company too, if you are wasting 30% of your time. So, enough with the challenges. Let's talk about solution. Amundsen is an open source data discovery platform, which was built initially by folks at Lyft in San Francisco. Yeah, it was named after the first person who explored both North and South Pole. Yeah, it's a name. So now I will be going to give you an overview of what the whole Amundsen application looks like on the front end, and then I will go more onto the details on the technical part, like the architecture of Amundsen. This is the landing page of Amundsen. As you can see, it is completely optimized for search. It has a big search bar on the top. And also, there is a new concept of popular tables over there. That's because if you are a new user on Amundsen and you don't really know what to search for, how to search for, then popular tables are there for you to kickstart your day. It's like what's the most commonly used or most frequently used table within your company, within your organization, within your team. Then you would search for something and you would get some results. Then those results are ranked, and they're ranked on relevancy and popularity. I will define each one of those very quickly. So, relevancy is fairly simple. If you would search for apple, you should get apple, not orange. That's relevancy. The results should be related to what you search for. And, And in terms of popularity, what popularity means? So if you would search for something, we would be showing you the results which are most frequently or most oftenly accessed or looked by the users. So people, if you would search for Apple on Google, based on the user's feedback, based on the user's interaction, you know that Apple as a company is really high popular than the apple as a fruit. That's popularity. So keeping the balance between those two, relevancy and popularity, has been a very interesting challenge. So relevancy score is based on some of the parts or the parts of the metadata, like name description, and the popularity is based on the querying activity. Querying activity is basically divided into 2 parts. One is automated queries, like a batch process or Airflow job or those kind of things. And the other one is ad hoc query. So if a user is trying to access your database, actual user, not the process, not the automated process, then that's the ad hoc query. And that should have higher weightage in the popularity. This is what the resource metadata page look like. In this case, this is table detail page. As a disclaimer, all the data that you are seeing in the screenshots, it's a fake data, it's a dummy data. I simply copied those images from the Amundsen repository on GitHub. Everything is publicly available. So table detail page, you see the description, you see the frequent user, like who are the frequent users. You also have the owner information, and you also have the column details. There are other things like Airflow or GitHub, it's like integrations. Amundsen is an open source tool, so it can be integrated with the different tools. If you would click on any of the column, you would see the column details, column statistics. Why column statistics are really important. Suppose if you're working on something, and you would see that there are like 50% of your columns have null values, then that particular column is of no use for you, because it already has like 50% of null values. All right, let's come back to the technical part. We are in the technical conference. Let's talk something technical. Amundsen follows a microservices architecture. It all starts from the front-end service. Of course, the UI part. If you would search for something on the front-end service, the search service, which is backed by Elasticsearch, serves the API request. And the things that you saw on the table detail page, that's a detail page, the metadata details. If front-end service would request anything from about a particular data source, the metadata service, which is backed by Neo4j, would respond or simply serves the API request from front-end service. There is another exciting component here, Data Builder Ingestion Framework, which is basically an ETL job. It is inspired by the Apache Goblin, and it is basically a set of Airflow DAGs, which fetches a different kind of metadata from different resources, from different sources, Hive, Spark, S3, or other things, and simply inject or index that data in Neo4j or Elasticsearch. That's the default architecture of Amundsen. What we did at ING, we simply replaced 3 things with Apache Atlas: Neo4j, Elasticsearch, and Data Builder Ingestion Framework. We had the contributions in the metadata service and the search service. We customized it. We added new proxy in the metadata service and search service, which now connects very nicely with Apache Atlas. And Apache Atlas is like a single store for data lineage and metadata, in our case, for ING. And everything is completely upstream. Everything is open source. It's already available in Amundsen repository. That's our contribution. So let's just talk about why Apache Atlas, why we chose Apache Atlas instead of Neo4j and Elasticsearch. Marek.
A quick recap, because I assume that not all of you use Apache Atlas or is familiar with Apache Atlas. So what actually Apache Atlas is? Apache Atlas is an open source data governance solution. It has a very rich built-in metadata type for various data sources, like, for example, HBase, Hive, Spark, Storm, whatever. And also comes with a set of hooks, meaning a set of integration with big data components. With the help of these hooks, it's very easy to capture changes in data structure and then lineage, which can be later captured and built in Atlas in a end-to-end lineage information. As I mentioned, out of the box has a support for Lineage. It also has a very nice support for tag-based security when combined with Apache Ranger. Because of that, it has a very nice feature of providing dynamic Ranger policy based on data sources tagging, and also tags population along the lineage information. It has a very, very, very powerful graph engine. This is why it's a good, perfect fit for searching using some connection between objects, and it can be easily integrated with other solutions. And of course, it comes with REST API. In order to address these two things that has been already mentioned by Verdan, namely the relevance and popularity in the search results, this is how we organize the data governance for this purpose. As you can see, we have two main sources of information, two inputs to Atlas that then are later on used by Amundsen who are doing the search for data sets. Namely, it's a data lineage and metadata. It is for this relevance part, and tables popularity score, which of course are needed for this information is needed in order to get the results scored by popularity of the objects. Okay, so let's take a look at the data lineage and metadata part. Everything starts, because it's a whole process, everything starts with data owners who are provided with a very nice web UI interface when they can describe and define data sources. We use Avro definitions, Avro schema definitions for describing the data sources. But we are not only focusing on defining the schema, but we are also using some properties fields. Properties so that we can, for example, add table description, column comments, and some other properties like, for example, data ownership and version of the data and stuff like this, which can be later on propagated to Atlas and help with the search in Amundsen. The schema information along with this metadata are stored first in the schema registry. Then we have developed another module called generic ingestion and generic data ingestion module, which is powered by Apache Airflow, Kafka, and Spark. And this process actually uses the information from the schema registry to onboard new data sources. So actually, it's responsible for the process of transforming flat files in our current state. And converting them into corresponding Hive tables and transcoding them into some binary representation like Parquet or ORC. Apart from that, because we are using Spark for running this process, we are also attaching two additional metadata. The first one is and we are using for that Spark Atlas connector. First of all, we are capturing the lineage, as already mentioned, so that we can have a clean link between the input, for example, CSV flat file, until the corresponding partition in a Hive table. That's the one thing. And the other one, we are also computing some data quality metrics along the way. This is why, for example, when doing a search in Amundsen and having some information that already was depicted by Verdan, you can easily check the information about the data quality on the table or column level. Here is a screenshot of one data source that we already onboarded and are using this generic data ingestion pipeline. As you can see, we have like a very simple Avro editor, and when we can define the schema, and also add some additional metadata like table description, column, comment, or some properties like owner, as I already mentioned. Here is the information once it's written to Atlas, because Atlas comes also with some basic UI. As you can see on the right-hand side, we have the lineage information starting from some flat file until the corresponding day partition in a Hive table. And on the left-hand side, we have some data quality metrics for a columns from the table. And the other source that is used for computing the popularity is this process for capturing the popularity based on Apache Ranger audits. So let's assume that we have a data scientist running some analysis using Python environment, which is in the final instance transformed in a SQL query and executed via any of the existing SQL engines like Presto, Spark, or even Hive. And then the access to the underlying resources or table or HDFS or both are provided by Apache Ranger. And then we have like two options. Either we have like a built-in plugin support for an engine like Presto or Hive, and the security is enforced at the table level. Then we have instantly the information about the table that is hit in a query. But in case, for example, of Spark SQL, when there isn't any reliable plugin for enforcing security at the table level, because by default Spark SQL bypasses the Hive plugin, then we need to take a look at and the security is enforced then at the HDFS level, of course. Then we can, then we are doing the following. So we are taking this HDFS path, and then using the information from Hive Metastore, we are mapping the HDFS path back into corresponding Hive table. And everything, this job is also written in Spark and scheduled via Apache Airflow. So this is how our data governance and data discoverability backend looks right now. This is what I already discussed in details in the previous slides. This is like an overall picture. As you can see, Apache Atlas is in the heart of our data governance, data discoverability process. This is how right now the data analytics platform looks like. So we have like a three main group of components. First is the modular analytics. Then on the right-hand side is the generic ingestion, generic data ingestion module. And in the heart we have this data governance and security. What is worth mentioning, almost all of these components are running right now in Kubernetes. Most of them are deployed via Helm charts. That's it. Okay, so what we are going to do next? So as we already showed you, right now our data discoverability is around data sets. So once you can search for data sets and various type of data sets. But in the phase 2 and phase 3, we'd like to first of all also focus on dashboards and people. For example, we can index Superset dashboard, because Superset is also one of the tools that is supported by that platform. And later on, we also would like to follow the same with the streams, schemas, and workflows. As I mentioned, some of the features were already implemented in Apache Atlas, like, for example, support for partitioning level lineage. But some of these things are still not yet available in Amundsen. For example, you cannot have the information about the lineage available in Amundsen. We are also working on the search performance and search improvements, because it's the core feature of our solution. It's our solution is as good as the search works, so we need to focus more on the performance of that. Later on, we are also going to work on the implementation on integration of Apache Atlas with Ranger for this stack-based security. So as we mentioned, as both Apache Atlas and Amundsen are open source projects, so maybe, Verdan, could you tell something more about the community?
Absolutely. So we are definitely open source advocates. That means that we don't really just use open source projects, we improve open source projects. We build open source projects. Everything that we work, we try to upstream that work for the community. That's our aim, that's our purpose. So this is a slide for the Amundsen users. So as you can see, ING is one of the prominent users, along with all others. This is for Amundsen now. And I'm really proud to say that we are the first one outside Lyft engineering to deploy Amundsen on production. And we have been working with the Lyft since the inception of their open source journey for Amundsen. So we are really proud for this work. About our team, we are located in 4 different locations. Main team is in Amsterdam, and then we are also located in England, Poland, and Romania. And we are growing. We are hiring definitely for the Poland, for the Warsaw office here. So if you're really passionate about the open source things, or if you really think that you would really like to work on the things that we just showed you, please have a chat with us after the conversation. We would be on the ING Tech booth. That's pretty much it. If you have any question, we still have 5 minutes left, I guess, so we can take questions. Thank you so much.
So if there are any questions, no questions, I think. Okay, one question. 1 second.
Hey, great talk. You mentioned streams, and this is a very interesting part because there is no currently a good solution for data lineage and discovery of streams. Can you say something more about your plans here?
Well, currently, there is some support for streaming in Spark Atlas connector, for example. But as we said, that is something that we are going to work only in the phase 3. So we haven't made any architectural decision yet on that.
Yeah, this is something from the community that have been recognized a couple of times on the Amundsen Slack channel. We have an Amundsen Slack channel, so if someone of you want to join, that's also there. Of course, the whole purpose for Amundsen was when they were building the Amundsen, they always have the open source concept in mind because every company has different concepts, every company has different needs. So there is some discussion about how to introduce or what to do for the streamings in Amundsen. So that's the reason it's in our future goals. It's not yet decided on how and when we would do that thing. Any other question? No? Another one.
One more question.
Yeah, I think it might be important. The data entry, the metadata entry. I think that you mentioned that metadata is rather collected automatically from the tables, from the ingestion pipelines you have. But is there also a possibility for humans to put the metadata in and to catalog the data and so on and so on?
Yes, as you saw on the picture, there is a web UI provided to the data owners when they define the schema and metadata. So the metadata are partially governed by manually, like for example schemas and metadata like ownership and stuff like this, and some metadata related to the quality and stuff like that are computed automatically along the way.